Hey, thanks everybody. I see people still piling in a little bit. It's great. So this is what we're going to talk about. Can everybody hear me? All right. What we're going to talk about it. What is Game of Hacks and what's behind it? We're going to have a little contest, not so wet t-shirt contest, but don't worry, you're not going to see me without t-shirt or in a wet t-shirt, so I will keep it PG. We're going to talk about Node.js, which is what Game of Hacks is written in. A little bit, show you a couple things and pitfalls to avoid. Nothing too technical, but it is going to be interactive, unlike maybe some other sessions that you've participated in. So pull out your laptops, your mobile phones. There's going to be quizzes and some prizes. So what is Game of Hacks, and how did we come up with the idea? Game of Hacks was designed when some of my colleagues were at a conference like this, though I think it was Black Hat, and they came across developers, or just attendees, standing and staring at the wall. And so when they came closer, realized that developers were just looking at some printed code, trying to find vulnerabilities in that code. Oh, interesting way to spend time, right? Instead of going to sessions or getting some cool giveaways from vendors, just kind of stare at the wall. But then we thought that we read this OWASP survey and realized that developers may not actually know a whole lot about security, application security in general. Right? And it's confirmed by CISO surveys, right, that their concerns are lack of understanding on part of developers, application security issues. And their challenges is to educate developers in application security. Right. So we put this, I guess, 1 and 1 together, 2 and 2 together. And we've designed this application on online web app, Game of Hacks. Launched it in August of last year at Black Hat. Was a pretty big hit. We had 35,000 participants within the first 24 hours, and I think that number obviously is much bigger today. We initially released it sort of as a marketing campaign, kind of trying to get attention to check marks and draw traffic to our booth, but it evolved into a bit more since then. So let's actually take a look at the game, in case you guys haven't seen it. So let me switch to my browser. Oh, I think that would probably help. I think this is it, right? I did run through a checklist of things getting ready for the session, but I guess connecting to the internet wasn't one of them. All right. So it's a series of quizzes that you can take. You can either play against yourself, right, and spend time, or you can play against friends, colleagues, etc. There are several levels available for you to choose from, right? Beginner, intermediate, advanced. And once you start playing, you kind of present it with questions. So can you guys see actually the text, the code? It's maybe difficult. Is that better? Essentially, you're presented with a code snippet, and you're supposed to answer questions about it. Answers are timed, right? And you get points the faster you answer. Well, obviously, you have to answer correctly. Anybody wants to tell me what the vulnerability is in the code? LDAP injection. Going once, twice. Okay, let's try it. All right, so that's how it works, right? You get, we got 1,900 points for this. It's a beginner question, and questions get progressively more difficult. The game is available free. You can welcome to play after the session is done, right? Not now. So let's go back. But that wasn't it. You know, once we've released it and we've decided to actually put some honeypots inside the game. We've developed the game using Node.js, and we'll talk about it a bit later. Trying to gather data on how Node.js applications can be attacked. For those of you who don't know, checkmarks, you know, we're in the static application security testing business, so various attacks on application code is of big interest to us and to our security research team. So we put some honeypots in, and going to tell you, didn't take long for the game to get hacked. So yeah, we did assume that it would be attacked, but I used some examples from you know, from conversations that we saw on various hacker forums. Basically, that hey, it didn't really take long. The game itself was harder than breaking it. So we learned a lot from it. I'm going to share some of that information with you, and perhaps you can avoid making the same mistake or using the same incorrect practices in your applications as well. How many of you actually do program in Node.js or plan to program in Node.js? Not too many, but yeah, it's a popular platform, becoming more popular. It makes it very easy to deliver I/O sensitive, I/O intensive, and parallel applications. So the architecture of the game is pretty simple, right? We have a client, a JavaScript client. We also have a Heroku server. It's cloud-based platform as a service, running our Node.js-based server, and the MongoDB as a backend. You know, MongoDB is very popular with Node.js developers. Fits very well with model used by Node.js, a JSON-based exchange of data. So, as we probably saw on the actual game screen, you know, there are a couple things. You know, there's a code that's presented. There's a difficulty level, a score, number of questions, et cetera, and a 60-second timer. Pretty simple. Okay. So we're gonna actually play a little bit of a game with you. So use your laptops, use your phones. There will be questions and as well as prizes for the top 5. All right, so go to Kahoot, and I'm going to start the game here. I'll give you a code to So that's the pin. I'm going to wait a few minutes for everybody to join. You can join by entering a pin on the Kahoot website. And for the rest of you who don't want to play, you can enjoy watching some web goats running around. Don't be shy. 2 players. All right, that's something. Guaranteed to win. If fewer than 5 join, guaranteed to win. So anybody here actually looked at Game of Hacks before coming to this session? 1, 2. Yeah, okay. So we did a version of this talk earlier this year. I can tell you the participation was much better. So, oh. Hmm. Hmm. Yeah, was hacked. Is that Wi-Fi is bad? Really? Is that? Okay. Well, that's a bit good number. Okay. All right. So we're gonna do 10 questions. Some of them are going to be hard. Some of them are going to be pretty easy. So question number 1. Are you comfortable in your seat? Yes or no? Okay. I take a hint. Well, let's get on with it. So it's your last chance to join. The first question gave you no points. So told you, some are going to be easy. Okay. So those of you I'm not sure which numeric system you rest of you were using, but yes, it is 4. All your base belong to us, right? Belong to us is on top. Now we're gonna get real. So we're gonna look at some code. Can you see it? Oops. I don't know. Is it better? Come on, just do a random number. All right. Okay. Well, apparently somebody did answer correctly. All right, go TK. Up to 1,000 points. So let's see if we can. I'm not sure why can't I? I can't make it bigger, sorry. Can't see it from there? Yeah. Sorry for those of you on this side, it might be difficult. But all hope is not lost, right? See, that one was, I think, maybe a little more difficult, but TK is still going strong. Where's TK? Actually, I think maybe some of you look young enough not to know what this cartoon is all about, right? See? Wow, it really tightens up at the top, huh? So we question 6. Yeah, it's going to be, again, difficult for those of you in the back and on the side. Three, two, one. Ouch. TK, I hope you did it correctly. Yeah, all right. So, if client presents answers in random order, what kind of limitation do we have? Can we run into? I think you can see it sometimes when you get login questions or something like that. So if it's only done on the client, by the client, not by the server. Okay. I guess the answer is that if client does random order, it would have to submit that order back to the server. Otherwise, server won't really know which answer was picked. Oh. So in this web application, you should be validating answers. Server, the client. Server, the client. Oh, the server, and we'll actually show you why it is, right? But I think most of you know. So what is the problem with this Node.js code? It's really just regular code. It doesn't have to be Node.js specific. But this is a server-side. Right, server-side code. Yeah, there's no check. What was answered before. You can actually just answer the same, send the same answer over and over again. TK, you should give up. You gave up, right? Come on, man. So the formula for calculating score in Game of Hacks was 60 minus time to answer times difficulty. So which part do you think can be hacked easily? I would go with 60. Right, time to answer. So, right, this is it for the contest. Tim and the rest of crew, come by, pick up your cool T-shirt, kind of like this one, right? We have some others, and the rest of you who didn't win, you can stop by our booth and get your own T-shirt anyway. But you would have to get scanned, so that's that part. And Tim gets it without getting scanned. It's pretty impressive, by the way, especially that Tom and Jerry answer. All right, back to so that actually was one of the honeypots in the game. The answered question. That little snippet at the end of the quiz. Initially, the server didn't really validate that the answer was already answered. right? So that allowed hackers to basically submit the same HTTP request over and over again and get their score run up. So a solution was to add a flag on the server to kind of keep track of what's been already answered. And similarly, in the real application, keep track of where the client is, really, or should be. The second honeypot was a timer. And that's, most of you correctly guessed that the score formula was hacked because the timer could be manipulated by just modifying JavaScript on the client. There's somebody posted a very helpful kind of recipe for doing just that very quickly. And of course, solution is to, well, calculate score on the server. So we moved calculations to the server, and there was an impact on the calculation, obviously, the latency between the time client sends the response and server gets it. But it wasn't really, it was negligible for the overall game design, and you can actually try to kind of mitigate that by looking at latencies and taking that into account. What else? Well, somebody actually I figured out that if you hold your thumb to your screen on iPhone while playing the game, you can stop the timer. I don't know. I certainly wouldn't really think about that up front, but the solution is the same, really, as to keep score on the server. And I think, in general, the message is to not do a lot of calculations on the client in general. So a couple of other Node.js things. You know, we have a kind of more generic things about Node.js. So first, let's talk about Node.js architecture on a high level. Node.js is a single-threaded event loop-based system. Right? We have an event loop that processes events very quickly, parses out tasks to kind of handlers, right? I/O handlers, file system, database requests, things like that. Registers callbacks, so when the long-running I/O application completes, callback is also placed in the event queue. So this event loop runs very fast, very quickly, constantly, allows the application to remain very responsive to users. Sort of in human terms, right? You have this fast food restaurant, and the single-threaded event processor then gives out tasks to handlers, right? So it works well for this distributed type of system. Where it doesn't work well is that if you have CPU-intensive tasks that you have to do, that would be tying up the single-threaded event loop, right? And that's actually the first thing you need to remember about Node.js. Do not put anything CPU-intensive in there, because a simple attack can be turned into denial of service. I'm going to show you a little demo. It's pretty quick. So something that calculates the sum of all integers from 1 to p typically runs really fast. All right, so let's So pretty quickly, right? Now, what happens if we do that but kind of increase the number? It takes a while, right? It takes a while to calculate, but since we only have a single thread, even our very simple example cannot proceed. Right? You will not be able to calculate a very simple 1 through 5 until the other thread finishes. So that pretty simple example shows you how easy it is to get denial of service attack on Node.js apps that don't not careful about putting CPU-intensive apps into CPU-intensive code into the main thread. I guess we're finished now. That's a long number, but keep that in mind when you design your own apps. That was the demo. What other things Node.js is acceptable to? So Node.js is a really JSON-based system, right? It has built-in tools to process JSON files. MongoDB is a popular backend. It stores JSON, allows you to retrieve data using JSON files. Essentially, doesn't require you to learn complicated SQL or even organize your data in structured table-like formats. So, for example, instead of using normal SQL kind of select from database users where user equals this and password equals that, it's a very simple single line query that you can do in Node.js. However, let me show you a little trick that basically JSON allows you to put conditionals inside of it, right? So this is a very simple login screen, right? That takes username and password, kind of lets you in or not. And so I can do admin, and I get in. But if I do admin something else, I don't get in, right? I don't really have to type anything, right? I can just put it in the URL. Same result as actual typing plus password. Right? So I can bypass the actual login verification by crafting correct JSON file using greater than files. There we go. So all I did was just put greater than A and greater than A for the username and password, and I'm in as an admin, because that selects all users with a username greater than A and password greater than A, or so where if you're not careful and not validating user input properly, easy to get application security breached. Now, a possible workaround for this is actually not to put a password inside the initial query, but to just get users based on username and then compare password using some other kind of method. Right? Now that opens application up to regex denial of service attacks. So the idea is that regex is a very CPU intensive operation, and as we just saw, Node.js doesn't really like CPU-intensive applications. And so instead of a very quick login page, I can paste something like this. Actually, it takes a while to paste into the. And a login screen will be hung for a while. I mean, I can obviously submit the even longer string for the regex and maybe come up with something that takes even longer to run. So keep that in mind. Node.js is very happy to execute all sorts of things inside JSON, evaluate and execute it. And so that opens the application up for various attacks. So how are we doing? We're actually doing well on time. So I'm gonna show another demo since looks like we're okay, and we're gonna talk about takeaways later. So another problem with Node.js is that is actually the default random number generator used by V8. You know, Node.js is executed by Google's V8 JavaScript engine, the backend. There's some research was done earlier on a V8 random number generator. Not going to go into too many details here, but essentially by guessing by knowing three consecutive random numbers, we can predict fourth and all the subsequent random numbers. So actually, maybe you guys can look at the code and tell me if you see anything wrong with it. Right? This actually is code taken from an authentication library, JavaScript-based authentication library, open source. And it generates a new user password. Right? And it takes random number, makes a string out of it, and hashes it with MD5. So what's wrong? I'm sorry, what? User. No, I'm not sure that's. Right, so math.random isn't really random. I think that's probably a bigger issue here. Well, it is pseudo-random number, but you're not supposed to be able to guess it anyway, right? It's not sufficiently cryptographically random. So it's random enough for certain things, but not for cryptography. Now, MD5, of course, is not a very good hash either, right? Not a very strong hash. You can quite easily break it, reverse it. So again, without going into too many technical details, just by knowing three consecutive random numbers from math.random, we can guess fourth, fifth, sixth, etc. So what's the angle of attack here? Right? We can use reset password functionality or new user functionality on the website. Right? Reset three consecutive user passwords that we know about, right? And then reset a password for another user, right? That new password will go out in the email. We don't have to actually get that email. We can figure out that password ourselves. And I'm going to show you how that works. Well, you send a you send a new password, right? When you reset a password, you send a new one to go log in and then change to something else, right? When you reset a password on the website, right? I forgot my password. Oh, yeah. Right, but how many sites are there? How many users are actually using two-factor authentication and all? Use token instead of pass. Yeah. So there are obviously ways to do it more securely, but I think sending passwords or getting new passwords in the email is for now at least very popular and prevalent, really. So what we have is an MD5 decoder, right? We actually went out and built a pretty big rainbow table, very nice, and I have this test website that's very secure. It has a picture of a lock on it. So we're going to do 3 consecutive passwords, right? Your user new password is it's actually pretty long and secure, right? Okay, so that was the first random number. Remember, we need 3. We're going to do another user. It actually is a rainbow table without MD5. It's 15 gig. We had to actually build it because we couldn't find an open one, an existing one. The random number generated by math.random is longer than what you typically see on the web. So it is our own, pretty big, couple hundred gig. All right, and so we have 2. Yeah, just brute force. Yeah, it's table, lookup table. Yeah. Okay. So that's our third. So now we calculate the next pseudo-random number. It's going to take a little bit. But, so here's the password that the next user will get. Let's see. See, so I don't really have to get your email anymore.
So if you put something besides user 3 in that box, it still works?
Yeah, just so the idea is that the first 3 emails or users you control, and the fourth one is can be somebody you want to attack, and so that fourth one you will guess. You'll be able to guess the password and then log in and.
It does rely on sequence, though.
Yeah, it does rely on sequence. So you want to, I guess, it could be that somebody else will generate the password. Yeah. But since you typically don't have to actually type it, you can just submit it pretty quickly and have a fairly be fairly confident that that's the third, that that's the 3, right? It will all be scripted, not manually. Yeah, you can generate all sequence numbers from here on out by just knowing 3 consecutive random numbers. And so this actually is a known issue in V8, and Google knows about it and not going to fix it, because in a normal browser, each tab has its own sequence, and so you can only predict the next number for your own tab, which is not very interesting, right? However, V8 is shared, one instance of V8 is shared by all Node.js threads sessions that are running. And so all Node.js sessions will share the same sequence of random numbers. So yeah, use a token. Don't rely on math.random. Use something else. But it's a pretty interesting vector of attack, so be careful. There's a research done by Amit Klein that goes back to 2009 about the weaknesses in V8 pseudo-random number generator, and we just took it and kind of put it in a demo and adapted it to Node.js. And so that's, again, when it was discussed back in 2009, it was really assigned a low priority, a low severity, because each tab is separate in Chrome. But once you apply the same thing to Node.js, that becomes a lot more exploitable. All right, I'm all out of demos for today. We have a few minutes left, so. I'm sorry, what? Yeah, the slides will be, the slides of presentation will be on the OWASP site. You can't really upload our rainbow table for MD5, but stop by to get your t-shirts if you're interested. So, thank you.